All right, the pectoral girdle connection to the axial skeleton is non-weight bearing, which is why it's powerful practice so much. The pelvic girdle is very much weight bearing. You can see how heavy it is. This arrow here, you don't have any notice for. That is the sacrum. If you want to learn how to spell that, you have to go to page 12. Near the top of page 12, the second section listed sacrum. That's what this is. And you can see this huge connection, weight-bearing connection between the pelvic girdle and the sacrum. Huge. Okay? That's all that. The reason why this picture is here is to show you the huge weight-bearing connection. All right. Look at the spelling of os coxa. You see the E at the end? What does that mean?
Singular.
Well, the E means plural. This is your spelling right here. Take off the E. Singular is os coxa. The os coxa has 3 bones. So this slide is not going to be numbers. You're going to write out the name of the bones. The top arrow is the ilium. Just write out ilium. This is a right os coxa lateral view, which means this is anterior, this is posterior. So the posterior bone is the ischium. It's nice and round, like that thing you're sitting on, because you're actually sitting on the ischium. And then over here is the pubis bone, and it comes to more of a 90-degree angle. So lateral view, this is nice and round, ischium. Pubis bone comes more to a 90-degree angle. Okay, everybody got the 3 bones? You wrote out the 3 names of the bones? They fuse to form a single os coxa. And this red line is showing you the approximate spot where those bones fuse. Those are the borders. This round cup is the socket of the hip, ball and socket joint. It's called the acetabulum. The 3 bones meet right in the middle of it. Okay, any questions? Okay, let's go over. Now this is right os coxa anterior, this is anterior. A lot of this becomes really intuitive. This is anterior on the side, anterior superior iliac spine, anterior inferior iliac spine. See how intuitive that is? So we're at 39 and 40, right? Iliac crest is 41, that's at the very top. And then you got the same thing on the posterior side. Posterior superior iliac spine, 42, and then posterior inferior iliac spine, 43. Right here you have a huge greater sciatic notch, that's 44. And the reason why it's a notch is because the sciatic nerve was there first, and the ilium formed around it. Okay? This will be very true when we get to the skull next week. A lot of these nerves were there first, some were blood vessels first, and then the skull bones formed around it. That's why you got a hole. Foramen. Everybody got it? All right, this part of the ischium is the ischial tuberosity. We'll skip 45 and 46 for now. We'll come back to it. And this right here is the pubic symphysis. So that should be 48
Which, can you point at it again?
on the side. This is the ischial tuberosity. A bunch of your hamstrings actually originate from that spot. That's why it causes it to be roughened and a little bit elevated. It sticks out. It's a plus. Okay, everybody got these? That is the obturator foramen, 49, and that's the acetabulum, 50. Okay. All right. Now for the rest of the ischium, we got to look at the posterior view. What I drew on the whiteboard way over there is basically this slide with the 5 arrows. Okay, everybody see that? The first two, what we covered already, posterior superior iliac spine, 42. Posterior inferior iliac spine, 43. And then you see what looks like a gentle number 3. Can you see that? I drew the number 3 in green. Can you see the number 3?
Yes.
The upper loop of the 3 is the greater sciatic notch, we already covered. The middle of the 3 is the ischial spine. And the lower loop of the 3 is the lesser sciatic notch. I didn't write numbers, I just put the initials. But you just got to see, visually recognize the number 3, and then it's really easy. But you got to look at the os coxa from the back, from the posterior, to see the 3. That's why I couldn't do this on the other view. That's why I told you just to skip it for now. Everybody got that? You have to look at the posterior to see the 3. Are we ready to move on? Had enough os coxa? This is showing you the ball and socket hip joint. The head of the femur fits right into the acetabulum. All right, so let's look at the femur. This should go hopefully a little bit faster. This is the anterior view. This is your longest, biggest long bone. This is the posterior view. Now, again, the femur is the only one with trochanters, and as you can see here in the posterior view, the trochanters really are on the posterior side of the bone. Okay, so don't worry about right or left for os coxa 2. There's a way of doing it. You gotta hold it up like you're looking at someone's crotch, and you've gotta be able to see this auricular surface that's not even on your best friend. So that's why I don't even ask right or left os coxa. But you do have to know right or left femur, and you want to write with that colored ink. The head and neck go medial, and the trochanters are posterior. And you can see the entire trochanters from the posterior. From the anterior, we only see the silhouette of the profile. Yeah, they do stick out, but you can't see the whole thing. You have to be on the posterior to see the whole thing. Everybody got it? All right, here we go. Let's do this first. You're, what number is it? Number 54. You're going to have to make it 54A and 54B because head and neck is not the same thing. So let's go through this. Head is nice and round, and this would be 54A. Here's the head. Another word for head is capitis. The word for divot, little divot, is fovea. So this is the fovea capitis. It's this little divot on the head. And you can probably see it from across the room in certain lights. On the medial side of the head is this little divot. That's the fovea capitis. Everybody see that? So this has got to be 54B. This is the neck. And it's kind of intuitive, right? the head and the neck. You see that there's a little distance between the head and the shaft or diaphysis. That's down here. You could call it shaft or diaphysis. But this is the shaft or diaphysis of the femur. But it doesn't go straight to the head. There is a little neck here. That's this. Everybody got it? Are you guys a little tired right now? Oh yeah. This is the way these classes are. If you've never had a class like this, it's because nobody actually pushes you like health sciences does. But some student in Tuesday lab was so tired, she goes, Ken looks like a penis. She said it out loud. I guess all her inhibitions were, she was too tired. And I said, disappointing penis. Okay, from the anterior, we can only see the silhouette profile of the greater trochanter. It is bigger than the lesser trochanter. Well, we can't see the whole trochanters because they're posterior. We only see the profile of them. Okay? Which ones?
Not the bottom one, but the next one up. Nope, the next one. Yeah.
That's the lesser trochanter.
The one above this.
That's the neck.
Okay.
Yes.
What's the last one?
This right here is the shaft or diaphysis. Guys said, the Tuesday students said you guys got all discombobulated. All right.
This is the head here.
Everybody got these now?
Yes.
All right. This is the posterior, and here you can really see all of the lesser and greater trochanter. You can see the whole thing, not just the profile silhouette. This is the neck, and this is the head.
Oh, it's the same thing.
The greater was on top.
Greater's on top. Now, when we use the word greater or lesser, it's really about relative size, not position. And even though this is on top, it's bigger than this one. That's why this is the greater trochanter, this is the lesser trochanter. Any other questions? Everybody got this?
No. Can you go over it again?
This is the neck.
Okay.
This is the lesser trochanter.
And then the top two? Yeah.
What's that?
The top two?
This is the greater trochanter, and this is the head.
Thank you.
See the head and the neck? The student said it kind of looked like a penis.
Yeah.
Small penis.
We're all distracted.
God, 50 years of teaching that class, that's the first time anybody's ever said that. Seriously, I mean, I shared that with you guys. You guys are like, what was the upper heresy? All right, can we move on? Can we get off the penis? I guess that gives the word boner a whole new meaning. All right, now, if you look at the trochanters on the posterior view, because again, they're posterior, it funnels down until the linea aspera. So the linea aspera is also posterior. Linea aspera on the posterior side of the femur's diaphysis. Linea aspera, what is that? 56? All right, on the distal end, anterior view, right where the kneecap goes and wraps around, is a smooth, polished surface we call the patellar surface. That's the cerebellum. Here's the patella right there. The smooth surface is the patellar surface. Oh, I'll just tell you right now, you do not have to know right or left patella. You do not have to know right or left fibula. I can tell which is right or left, but you don't have to. Oh, and here's the easy way to do femur. I mean, yeah, you can do, okay, the head is medial, and the trochanter's a posterior, this is a right femur, or you can just hold it out like a gun. The way the condyles go, if the condyles go right when you hold it like a gun, it is right. If it goes left, it's left. So that would be a gimme point. All right, posterior view, we can see the condyle. So this is a right femur. This is the lateral condyle of the femur. This is the medial condyle of the femur.
On the last one, it says patellar.
Surface.
Yes, and then it says patella.
Yeah, and this is the patella right here.
So on the test, no R, just the A?
Yes, because that's, the actual name is patella, but things having to do with it is patellar. And this is the smooth surface of the anterior distal femur where the patella rubs against. It's smooth and it pertains to the patella, so they call it the patellar surface. Okay, everybody got these? You do have to name now on the femur and the tibia, medial and lateral. That's how it's listed on page 8. On page 9, the trochlea and the capitulum are the condyles. You do not have to say medial or lateral epicondyle because it's only listed as epicondyle on page 7. Yes?
Can you say the names of those two? I missed them.
This is the lateral condyle of the femur. This is the medial condyle of the femur. Yes?
So you're gonna have to add
Of the femur, because it's also listed the same thing under tibia. If it's on multiple bones, you have to say of the bone. So styloid process, you have to say of the bone. Coronoid process, you have to say of the bone. We got one on the ulna, we got one on the mandible. Everybody got it? Any questions? It's got a lot more questions. So here's how the knee comes together with the patella. Patella is a sesamoid bone. We all have different sesamoid bones, but you pretty much have a patella. There are very rare exceptions. People don't have kneecaps. But on this picture, I want you to show you this. Okay, let's do some education that everyone can know. How many bones do you have in your leg?
2.
Two.
2.
Two. The leg goes from the knee to the ankle. This is your femoral region or thigh. Your leg goes from the knee to the ankle. Everybody got it? So we have 2. Now look at the bottom of page 8. And from the list of the things that they listed under tibia and fibula, someone tell me which is the lateral bone in the leg. Just look at the list of things you. It's the fibula is the lateral bone, it has the lateral malleolus. Tibia is the medial bone, it has the medial malleolus. Everybody got it? Now, one of the things that would be helpful is actually looking at comparative anatomy, like four-legged creatures. And we used to have the horse's skeleton here, but we had to move it to the library. But the hind limb coming out of the trunk of the horse is actually the horse's leg. Because the horse's femur is so short, the knee joint is actually coming right at the trunk. Did you guys know that?
No.
If you look at the rear or the knee of the horse, it looks like the knee bends backwards, right? That ain't the knee. That's the heel and the ankle. Like this. It's actually bending like this does. It's just that the horse has really long metatarsal and phalanges. Everybody got it? But the femur's really short. It barely comes out of the trunk. If you've got to look carefully to find the horse's knee. And then what's coming out is actually the horse's leg. So you tap the hind limb of the horse, that is actually the leg because the knee is so up there against the trunk. And actually the horse is actually running on its middle digits. Did you guys know that? It's running like this, middle fingers, middle toes. use every excuse I can to put muscle. And the way you put the horseshoe is on the middle finger and middle toe fingernails and toenails. That's where you put the horseshoes. Isn't that wild? Horses are weird, huh? But that backwards knee, part of that is the tibia, and part of that is the middle, metatarsal number 3. And it's really long, okay? I don't know. Okay, so, but when you look at this, this is what I want you to get out of this. 100% of the weight on the femur goes to the tibia. 0 goes to the fibula. All of it goes to the tibia. And the condyles match up. And so this is a right anterior view. That means this is the medial condyle, and it articulates with the medial condyle of the femur. And this is the lateral condyle of the tibia, which articulates with the lateral condyle of the femur, 1 to 1. All the weight goes to the tibia. So if you look at this knee joint, you can actually see the head of the fibula right here. And it doesn't has anything to do with the femur. It's actually tucked underneath the lateral condyle of the tibia, as if the tibia is a patio roof. If it was raining, the fibula wouldn't get wet. You following me? No weight is going on the fibula. The fibula is underneath the lateral condyle of the tibia. 100% of the weight is going to the tibia. That's why it's the big leg bone. Fibula looks like this little pencil. In between the tibia's condyles is the intercondylar eminence. And this is the tibial tuberosity, and you want, with that colored ink, you want to write anterior. Tibial tuberosity is anterior. The medial malleolus is going which direction, you think? Medial. So that's the other one. There's your 2 planes. This is anterior, medial malleolus is medial. All right, if you follow the tibial tuberosity down, you get to the anterior crest on the anterior side. Can anybody tell me what's on top of the anterior crest? Hypodermis. There's no muscle over it, it's just skin. Which is why when you're sneaking in your house and it's pitch black and you run into the coffee table, why it hurts so much? Because you just pounded periosteum, which has a ton of sensory neurons. There's nothing protecting that bone, it's right there underneath the skin. Everybody got it? I mean, you can feel the anterior crest. You can feel the edge of the bone. You guys are suffering from a grotesque lack of curiosity. Feel the anterior crest. You can actually feel it. And if you kick the coffee table, you know what you just kicked. And nothing over that. That's just skin, epidermis, dermis, a little bit of hypodermis, and boom, you're on the anterior crest. Everybody got it? Medial malleolus is medial. That's kind of how the 2 articulate. Little thin fibula underneath the lateral condyle. It's underneath, it doesn't even articulate with the femur. And here's the lateral malleolus here. And that is actually pretty accurate location. This is the head of the fibula. It looks very abrupt, like a cauliflower flower. And then the lateral malleolus is a smooth teardrop shape. Oh, does it look like a broccoli flower? Smooth teardrop shape for the lateral malleolus. Okay, so here's the malleoli. Medial malleolus of the tibia and the lateral malleolus of the fibula. Look at this level of the arrows on this picture. Look at the level of the arrows. The medial malleolus is slightly superior. Put your foot flat on the floor. Put your foot flat on the floor and feel those bumps on the lateral sides. Go ahead. Okay. Medial should be higher, lateral should be lower. Unless something is messed up with your anatomy. There's the medial malleolus here. And this right here is the talus. So you gotta go to the page 9, we're almost done. This is the talus on this side. 100% of the weight of the femur goes to the tibia. 100% of the weight on the tibia goes to the talus. I need to get more whiteboard, so I gotta erase. I'll erase this over here. Everybody got these terms: cortex, cortical, medulla, medullary, inner, outer. I'm almost done with this. I'm gonna erase some of my. So you don't need to know right or left on the top of page 9 either, because it's always going to be a right foot superior view. A lot of things I'm covering is making it easy for you if you're listening. Again, only 7 tarsal bones. So the talus is here, this is calcaneus, this is navicular, this is cuboid, medial cuneiform, intermediate cuneiform, lateral. Okay. So for our species, the foot is different. Here we go. You guys ready? Not yet? Are you ready? Again, while there were 8 carpal bones, there's only 7 tarsal bones because 2 fused to form the calcaneus. It's big. Carpal bones are in the wrists, metacarpal bones are in the palm, phalanges are in the digits. It is different with the foot. Tarsal bones is ankle and proximal foot. Metatarsals are just in the arch of the foot. The proximal phalanges are still in the foot. It's the joint between the proximal phalanges and part of the proximal phalanges that form what coaches call the ball of the foot. Has anybody heard coaches say that? You got to get on your toes, get on the balls of your feet. You're actually getting on your proximal phalanges, which are still in your foot. Only the little distal ends of the phalanges go into the toes. You know, just look at your own feet. You know, unless you're a monkey, and then you got a tail, and then everything gets weird. If you're a monkey, everything like this is actually very similar to that over there. But for us, it's different. Tarsals are not in the ankle, they're the ankle and proximal foot. Metatarsals, arch of the foot. Proximal phalanges and the joint to the metatarsals, the ball of the foot. And then just the very distal end of the proximal phalanges goes into the toes. But then it is parallel that the hallux, big toe, only has 2 phalanges. Proximal and distal. The other regular toes, 2, 3, 4, and 5, has proximal, middle, and distal phalanges. Okay, so let's go over this. The X is the talus. All the weight goes to the talus. The biggest one here is the calcaneus, it's huge. Then you got this wafer, this curved wafer bone, I just made it a thin rectangle, it's the navicular. This box-like one is cube shaped, so they call it cuboid. So I can't just use C, you have to use calcaneus and cuboid. And then you got the three cuneiforms. Medial cuneiform, intermediate cuneiform, lateral cuneiform. You can call it first, second, and third, but if you use medial, intermediate, and lateral, it'll remind you by its position. Because everyone's big toe should be medial, unless your anatomy's really messed up. Okay? Any questions? So again, here's the, well, if I did this, what would your answer be? Metatarsal Roman numeral 1. Let's go to the big toe. Metatarsal Roman numeral 1, 2, 3, 4, and 5. Phalanges does parallel the hands in numbers. So this is proximal and distal, proximal, middle, distal phalanges. Any questions? Everybody got the tarsals and metatarsals? Anybody missing any arrows? I bet you guys missed this one. That's a lateral malleolus. Any questions? I'm gonna stay in grade here. I'm gonna go up and close my office up before I hit the road at 4 o'clock.
Did you get these ones?
All right. Oh, let me also explain something else to you. You guys listening? Traditionally, when I was running Open Lab, administrating it, since we're done with microscopes, we had Cal Poly division and graduate students manning the Open Lab starting at the end of week 3, which is tomorrow. Traditionally, Open Lab is Friday and Saturday, 9 to 4, starting in week 3, which is tomorrow. The administration doesn't want to pay anybody to do it. They said, well, we will do it. And I said, you don't know how to do it. I've run this thing for over